This is October-November 2024, paper 1-2. We're going to go through the marking scheme and how to solve the question. But before we move on, I want to show you what were the marking criteria. So if you had to score an A or above, you would have to get 28 marks. But if you wanted to score an A star, you would have needed 35 marks. I've reworked this backwards from this 158, and I've calculated that this should be 35 out of 40 if you want to hope for an A star. But anyways, let's go on. Let's move on. Question number 1. Again, this is October-November 2024, paper 1-2. Question 1. He says, what would you use to measure this height? Now, all of them can be used to do that except for the measuring cylinder. That's for the volume. But for the first 3, we can use them. But the best one or the most accurate one would be a micrometer. So this should be option C. Question 2. Which set of quantities and all vectors are all vectors? So this is vector, vector, vector. This is scalar, scalar, scalar. Extension is also scalar. Force is vector. Energies, all type of energies are scalars. Weight is a vector. Kinetic energy is a scalar. Work is a scalar. So all vectors is only option A. Question 3. He says graph shows, it's a distance time graph, and we understand that the gradient represents speed. If it had been a displacement time graph, then it would have been velocity. And we can do this by change in y over change in x. Just analyze the unit. So the unit on y-axis is meters. The unit on x-axis is seconds. So this would become meter per second, which is definitely the unit of speed. Now he's asking you about the average speed, which would mean that it is going to be about the total distance covered by the object divided by the total time taken by the object. So the total distance by the object will be the end of the journey, which is this point. This is 28. And since he mentioned it is for 14 seconds, we can read this from the graph, or you can just take it from the question. So this will be 28 meters covered in 14 seconds. So this simply comes down to 2.0 meters per second, which is option A. Question 4. The velocity of the train varies, but since it is a velocity time graph, then we have to pay attention to the direction. So he says in which section the graph is decreasing. The magnitude of velocity is decreasing, which means it should be slowing down. Now, in the first section, we can pretty much see that very clearly, that the velocity is decreasing, which means consequently, it is slowing down as it's moving along. So section P goes for this situation. But what happens at this point? You see, the velocity becomes 0, which means that the train has stopped at the station. And when we see that it is in section Q, it means, the negative velocity means that it is now going backwards, or it's starting to go backwards the way it came from. So for example, we see this very commonly between 2 points. Let's say this is point A and this is point B. The trains would have 2 engines, one that pulls it to this direction and one that pulls it to this direction. So the train travels and reaches, let's say, a certain point, stops for a while, and then starts going back again. This is what the negative section of the velocity represents. Again, reading the velocity from the graph. It reaches a certain maximum point or a maximum speed or maximum velocity while going back, coming back in section Q. This was your section B. It was moving forward, but it was slowing down. For example, taking a break before a section appears, before a train station appears. Then it started to go back, and at this point, it attained its maximum speed going back, but then it started to slow down again while going back. And how do I know this? You can see that the gradient is positive. The acceleration might be positive, but it's positive in this direction. And also, notice that the value of the velocity is becoming less negative as the time is passing by. You see, if you analyze the section R only, you will realize that the value of the velocity has started to decrease. If you pick any point, it is going towards 0. Eventually, it stops at this point. So, if it had maximum velocity going back and started to slow down because it has to stop, that means in section R, the velocity must also have been decreasing, which is why section B and R qualify for this decreasing velocity magnitude, which is option B. We move on to question 5. It says, which property is unchanged? Now, generally, mass is unchanged, but how do we look at the other properties? If you squeeze it from the sides, definitely the radius would decrease, the distance between the atoms would decrease as these atoms or the solid particles would start coming close together. But what about the force between the atoms? It will increase. Why? Because in the solid structure, they're already tightly packed. If you start squeezing them from the outside, the force that you applied from the outside gets transferred to the next one, and it is, of course, coming from both sides. Now, according to Newton's third law, if you apply a force on this one, this ball will apply a force back on you, which is why, since there already is no space to shrink even further down, the force that you apply will be applied back to you, which is why the force between its atom appears to have increased, because they will be providing that force back to you because they don't want to shrink. But again, if you go to higher levels of chemistry, you realize that there is always an actual crystal lattice structure between the atoms, and of course there is some distance between the atoms, which is so small that it's really not shrinkable, or you can say we really can't decrease the size even further. All right, question number 6. So the answer of this question would be mass. The mass remains unchanged because mass is the number of atoms. The number of atoms, however many there may be in this ball, are going to remain the same. This is a very common and repeated question, but let's go through this. He says there's a weight and there's a mass of the satellite. They're moving away from the Earth. Okay, fine. He says which statement is true. So both mass and weight are unaffected. You see, mass is unaffected, but the weight is not unaffected because weight is equal to mg. Now, as you move away from the surface of the Earth, the gravitational strength at the surface is higher. But if you move away from the surface of the Earth, the gravitational field strength at this point will be lower because the gravitational attraction at this point, while you're moving away, is a bit less. The reach of the Earth's gravitational field is a bit less, which means that the value of g is smaller. If the value is g smaller, the value of the weight will also be smaller. He says the mass decreases. So since the first statement is wrong, I wouldn't bother reading the rest of it. The mass increases. Again, the mass is not going to change. I will not bother reading the rest of the statement. Question part D. The mass is unaffected. True. And the weight decreases. True. Because as you're moving away, the satellite is moving away, the value of g decreases, the value of weight also decreases. So the answer will be option D. Question 7. A material has a density. I know this was a question that was really uncalled for. They haven't done this in a while, but it's a really straightforward and easy question. He says, convert the gram per centimeter cube to kg per meter cube. Now, a student who has practiced these questions many, many times, you would realize that at the end of the day, it comes down to a factor of 1000. If you want to go from grams per cm cube to kilograms per meter cube, you multiply this value with 1000 and you go to this one. If you want to go back, you divide it with 1000 and you get grams per cm cube. In this case, if you multiply this value with 1000, answer becomes option D. You can choose to convert this into 1000, converting this into kilograms, and then converting cm cube into meter cube separately, and then trying to divide it. But really, it's all down to memory. You shouldn't waste a lot of time on this question. Question number 8. An object falling through air, which diagram represents the forces acting on the object. Let's do a true-false. So force of air on the object, yes, because if you're moving down, then generally the drag is always acting upwards. The direction of the drag is wrong direction, correct direction. Let's look at it from the perspective of the Earth. The weight is always downwards. Let's try to see if that is one of them. So correct direction, correct, false, false. So the only option in which I can see that both directions are correct is option A. Again, an easy, straightforward question, but I've shown you how you can do this by elimination method. Question number 9, a repeated question. In a different format, he says, which expression gives you the moment of force F about the pivot? You see, the pivot is already given, and we understand that if I want to find the moment because of F, there needs to be a perpendicular distance. Now, L also appears to be a distance between the pivot and the direction or the point of application of force, but the problem is, it's not perpendicular distance. This angle or this angle is not 90. It has to be 90. So if I look at the value of, or if I look at the distance D, I realize that the angle between the distance and the force is 90. That is why we say that it is actually the perpendicular distance, or the perpendicular distance with the force. So if I want to multiply a moment or find moment, the D multiplied with F, this has to be perpendicular to the force, and it's only D. So option C would be the right answer. Question number 10. A rocket. Okay, so this is our rocket. is experiencing thrust in the upward direction with 3.5 meganewtons. I'm ignoring these units because I know what their value is and I will deal with it later. The average air resistance, again, if the rocket is moving upwards, then the drag would be downwards. So this will be 0.1 meganewtons, and the weight of the rocket, which is again trying to pull it down, is 1.9 meganewtons. So if you just simplify this, there is a force trying to pull it upwards with 3.5 meganewtons, and there is a force downwards. Collectively, because they're doing the same job, I will add them together. So 2 meganewtons is what this rocket or the engines of the rocket have to encounter or overcome so that the rocket successfully keeps on going forward. So the resultant force or the extra force that the object is experiencing will be 3.5 minus 2.0, which would become 1.5 meganewtons of resultant force. Now this force is responsible for carrying it upwards or to taking it to a larger height or a greater height, which is why we're using this force with the distance provided in the question, because we know that the work done is actually force into distance. Now I have figured out the force. If it had moved 100 meters under these certain conditions, then definitely this is how we are going to deal with it. This is how the numbers are going to be calculated. This is going to be option A. Now, why is it mentioning this first 100 meters? Because as the rocket gains speed, the air resistance will start increasing because the drag is directly proportional to speed. Although this idea is not related to this question, but I've mentioned this because the equation drag being proportional to speed is often ignored by the students, which is why I've added for this question with a good reference. It's not required here. Question number 11. Which equation is used to calculate efficiency? Now, it's a really good question in terms of formulas, but let's ignore the formulas which are really impossible. First of all, the multiplication is always wrong. Division in terms of option C, look, energy being divided by power. This is again wrong. Why? Because irrespective of output and input, the unit on the numerator and denominator should be the same. It could either be energy divided by energy, or it could be either power divided by power. Be that input, output, that's another discussion. But it has to be with the same unit. Why? Because efficiency is a percentage. It's not a quantity. It will never have a unit. That's why joules will be cancelled with joules and powers, watts, will be cancelled with watts. It has to, which is why the units should be the same. I'm ignoring C primarily because of this reason. Then option B is wrong. Why? Because we're not looking for total power in the numerator. It's actually going to be in the denominator. So total power in the denominator, useful energy output in the numerator. Option A is the right answer. And again, you can recall this from memory. I'm just going through this in terms of logic and reason. Question number 12. 4 objects, different masses. Okay, fine. If they're being lifted, then it's a lift question. And we know that if I wanted to find power, then the formula for power is equal to energy divided by time. And what type of energy is being employed in this question when it's about lifting? That's gravitational potential energy, which will be mgh divided by time t. Now, before we get into these solving, okay, so let's try to solve one situation so you can solve for everyone. So if I'm trying to find out power, so we have mass m and the value of g in the question. Let's assume that to be 9.8. Although if I was doing this in the exam, I would assume g to be 10 so that it makes my calculations easy. But then again, if you're looking for accuracy, you can try that. So 2 kilograms multiplied by 9.8 multiplied by h, which is the height or the distance traveled in the upward direction, which should be 2, divided by how much time was taken to do this job. It was 3. So power in this case comes out, let me just refer back to the notes. Okay, so the power in this situation comes out to be 13.1, but for the sake of argument, I'm taking this as 13 watts. I've done the same thing for all the other options, which is P in this case would be 18.4 watts, but I'm taking this as 18. Okay, what the hell? So let's take 18.4. So power in option C comes out as 26.1 watts, and power in option D comes out as 24.5 watts. Now, if you do this, it takes you a lot of time. And now we can clearly see that the greatest power transferred is in option C. Perfectly all right. Really good practice. Fine. But you won't have this time in examination. Of course, you're under pressure. You might not realize where the first 10 or 15 minutes have gone past. And you're really left with only 40 minutes to solve these 40 MCQs. So if you were to make this choice, if we are looking for the greatest power, let's look at the equation, which should be P equals to mgh divided by T. If you want this power to be greater, then mathematically speaking, you can't change the value of G. That's natural. You should be looking for a higher value of H and a higher value of M, but a smaller value of T because it's inversely proportional. But keeping that in mind, if I had to make a choice between mass of 2 kg and 1.5 kg, I would select 2 kg. Now, since option D also has 1.5 kg, I'm rejecting this on the basis that it doesn't have the largest mass. And then if I have to make a choice between the largest height, it's 2 meters and 2.5 and then 2.5. I would again prefer the 2.01 because I can see that the time limit in these situations is much more violent, or it is much more stringent in terms of its values. Again, it's a way to guess it. It's a way to make an educated guess. If you still want to go down calculating these things, it's up to you. It's completely fine. So again, if I had to make a choice between the times, I would be choosing the smallest time, which is 1.5. So doing this quickly means you are trying to do or trying to give more power. So again, by the standard, you would at least be eliminating at least option A and option B, even in the simplest cases. Then you can try option C and D and see what happens. So you will eventually come to option C. Question number 13. Whenever it's about the question is about air and pressure, Newton per meter square, especially this is a new thing I've seen with the examiner, then instead of giving pascals or the unit of pressure, he started to give out newtons per meter square, which is definitely pascals. Because for pressure, it is force over area, and for force, that is newtons. For area, it's meter square. So looking at this is not a problem, but then again, it's just an added level of difficulty to cause confusion to the student. Whenever you encounter a question related to gas pressure, always go back to the Boyle's law equation, which is P1 V1 equals to P2 V2. 99% of the chances are that this is what he's going to use in this question. Let's see. So he says that the pressure in this situation, and the current situation, was 1 power 1 into 10 raised to power 5. Now, do I know the volume just by looking at the height of the cylinder? Let's see. And P2 is what we need to find out because now he is compressing the container by moving it downwards. So the height becomes 0.15. Now, is this height actually the volume? That's the problem. Now, what you guys would do generally is you wouldn't pay any attention to the fact that this is height of the cylinder. If you wanted to find the volume, because that is what the formula requires, you would use the formula which is pi r square h, the radius of the circle of the piston, and then using this formula. But what happens right now is that since even if you had calculated this area or the cross-sectional area this way, if the piston moves downward, the piston still has the same cross-sectional area, which is pi r square, or would still have the same formula, at least up to this point. So if I replace this in this equation, which becomes pi r square multiplied by 0.18 and pi r square multiplied by 0.15, naturally it cancels out from both sides, which leaves us with this equation, which is 1 into 10 raised to power 5 into 0.18 equals to P2, which we want to find out, into 0.15. Now, the problem is, again, going back to the main concept, you might see this in the solution and think that this height was actually the volume, but this is wrong. Volume did need pi r square, but since it was same for both cases, that's why it has been cancelled out and you only see this number. But don't forget about the concept, because in P2, they would challenge you on this and would want to see how have you dealt with this problem. Are you putting these values directly? Because that means you don't know that pi r square is actually getting cancelled. But anyways, now my expectation should be that if I'm pushing the piston down, if I'm reducing the volume, the pressure should increase. So even if I had to make a guess and if I had forgotten about these equations, I would not go for equation A and B because they are showing that the pressure decreases. It shouldn't be possible. If you calculate this equation completely and more accurately, your answer will come out as option C, which is 1.2 power 10 raised to power 5. Question number 14. Now 14 was based on knowledge, again, not accessed in recent years, but he has been surprising in many questions. He says that is kept at a constant volume. And he wants you to see what happens, or he wants you to tell him that if the temperature changes, how the change in temperature affects the pressure in the gas. Now he uses the word change. He's not telling you if he's increasing it or if he's decreasing it. What he's trying to see is, do you know what happens? So we know from this table, you can take a screenshot and add this into your notes. These are three things that happens in terms of gas pressure. This is what we are most familiar with, Boyle's law. And the other two rules we are familiar with in terms of general life experiences. That if you increase the temperature, the pressure increases, like in the pressure cooker. Same thing happens in real life. If you increase the temperature, the volume increases. Something like that happens with a rocket. Something like that happens inside the pressure cooker. But although the volume in that pressure cooker is constant because you're forcing it to be that way. If you hadn't allowed, if you hadn't fixed the volume, but if you hadn't closed the container, then definitely the gas molecules would want to move away from each other, which you have prohibited, at least in case number 2. But anyways, since he says that the volume is constant, I will rely on a system in which volume is not being discussed. So it actually becomes case number 2. And it's a direct proportionality, again, based on common sense or common understanding. So we will choose that if it decreases, okay, fine, I'm fine with that, but the pressure should also decrease. That's why I'm rejecting option A. If I'm decreasing the temperature, okay, fine, the pressure remains unchanged. No, this is false. The pressure also has to follow the same rule, so B gets rejected. Option C, the temperature increases, okay, fine. Pressure increases, yes, this looks good. Option D, temperature increases, okay, let's check, pressure unchanged, no, false. So option C seems to be the right answer. Option D is also wrong. It never stays unaffected. Question number 15. Again, he wants to remember, or he wants to check whether you remember this equation, that if you want to convert this into Kelvin or Kelvin scale, you will add 273 and your answer will directly be 1337. Question number 16, he says there are some melting points shown, and what I've done is to explain this question to you much more easily is I've made this image on the side, although it's not in the past paper, but it's for you. Okay, so let's zoom in with the question. Now, argon is represented with the red color, nitrogen with blue one, and orange with the brown, and oxygen with the brown one. So he says that the melting point for argon is minus 189. So this will be the melting point. This will be the boiling point, which is round about 185. Of course, I understand that it's a bit on the higher side, should be in the center, but we can ignore that. So what does that mean in terms of the state of the object? So if it is below the melting point, it will be a solid. In this tiny sequence, it will be a liquid. And beyond this, and beyond this, it would become a gas. Same thing happened with the nitrogen. So for nitrogen, we have a melting point at minus 210. So this is my melting point. And this is our, let's say, boiling point at minus 196. It's like a number line system, right? So over here, it is a solid. In this section, it's a liquid. And this section, it becomes a gas. Of course, we're going up. Or if you increase the temperature, this is what's going to happen. Or we're expecting it to happen. If you go towards oxygen for the third one, minus 218, somewhere along this line, this is going to be my melting point, and this is going to be my boiling point. So below this point, it was a solid. In this section, it was a liquid, and in this section beyond, it would be a gas. The question he's asking us is that what is the temperature when the three elements have different states? What you can do is try to test all the 4 options and see where all of them are different. But in option C, in a minus 190, let's see what happens at minus 190. So at minus 190, we can see that if I go across the board like this, so the only confusing bit is this 189, right? So minus 189, or at minus 190, argon would be a solid. Nitrogen, because it's crossing the gas boundary, would be a gas. And oxygen, because it's in this region, would be a liquid. So this is that temperature where all 3 would be at a different state. So I've explained this in terms of the mathematics number line. You can use this logic for melting and boiling points. It makes the life easy. Question number 17, he says evaporation. We are very familiar with the factors of evaporation. He says loss of liquid reduced by evaporation. Let's analyze all of them. Blowing air increases the rate of evaporation. Heating the liquid increases the rate of evaporation. Putting a lid decreases it because molecules will find it difficult to escape. Transferring the liquid to more surface area. So surface area increases the rate of evaporation. Again, if you cover this with a lid, a lot of gas molecules or the vapors have already converted. There is no more space for more molecules to actually escape the surface of the liquid and become the part of the gas in this space. So this would be option C. 18, again, a fact-based, memory-based question. He says, the best absorber of infrared radiation should be black and it should be dull. So option B would be the right answer. Question number 19, he says, give the wavelengths and the speed is given. So which one of them is actually ultrasound? Now, this is an interesting question in terms of your knowledge. You see, ultrasound are those frequencies of sound waves which are greater. So if frequency, I'm calculating frequency, it should be V divided by lambda. And any answer greater than 20,000 hertz is actually called ultrasound, which means that even human beings can't hear it, because the range of audible, the audible range is actually 20 to 20,000. So 20 hertz to 20,000 hertz is what we can hear, a healthy human being can hear. So the only choice you have is calculate for all of them. We can't really guess our situation. So in this case, it would be, now one thing, notice that this is centimeters. Okay. So don't forget to add the centimeter prefix. So I'm going to show this for one MCQ, for one option. You have to try for all the rest of them on your own. So let's try for option A. So this would be 330 according to this formula. 330 divided by 6.6 into 10 raised to the power minus 2, because it's centi. You can divide this with 100 by the other mathematical procedure, but that's your choice. So in this case, the value comes out as 2000 hertz for the first case. The second one becomes 1000 hertz. The next one is 25,000 hertz, and the last one is 16,000 hertz. Now, all of these frequencies, we can hear them. They are within the range of human audible frequency. We can hear this, we can hear this, we can hear this. But anything greater than 20,000 qualifies for an ultrasound. So this is the option, the 25,000. So correct answer will be option C. Question number 20, a repeated question from the past. He says, what's the angle of reflection or be that incidence? So you would always draw a normal. And the angle of incidence or reflection is always referred to with the normal. So this angle would become 60 because we know the total has to be 90. So 90 minus 30 gives me 60. So really, this should be option B. Question number 21, he says, recall the properties of plane mirror. Do you know them? And I hope that at this stage we do. It says which one is the right one. So you see, let's reject options based on the common understanding. You see, it has to be upright. So it means if this is the head of the object, then the head of the image should also be on the same side. So B rejected on this basis, C also rejected on this basis. The other thing that's wrong, or that should be checked, is about the equal distance from the screen up to the image. So if this is the distance up to the mirror, the distance of the image should also be the same. Now option D says that the image is on the mirror, which is wrong. It's always inside the mirror. And just by inspection by eye, I can see that the distance of both these images is equidistant. So option A is the best answer. Question number 22. Which ray diagram? Okay, the ray diagram represents something. Critical angle. Okay, fine. So to find critical angle, the first thing that you're supposed to do is find the refractive index. And how do you do that? You need to use the formula sine of I divided by sine of R. Now the problem is that over here the angles are given to you indirectly. So this is my angle of incidence or incident ray, and this is the reflected ray. I'm supposed to calculate this angle, which will of course be found by subtracting with 90. So this becomes 48 degrees, and this becomes 90 minus 49.5 becomes 40.5. So these angles would become sine of 48 divided by sine of 40.5. This comes out as 1.144. Yeah. This is your refractive index. Now the formula for critical angle is refractive index equals to 1 over sine C. Or sometimes sine C equals to 1 over refractive index. Your choice, whatever you want to start trying. So we have the refractive index from the previous part. It doesn't change. So let's put it this way. So let's take sine inverse to the other side. So C is equal to sine inverse of 1 divided by 1.4144. When you calculate that, your answer of critical angle would become 60.9 degrees, which is option C. Again, you can add more steps mathematically to make it easy for yourself. Question number 23. From the electromagnetic spectrum, so the electromagnetic spectrum is gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, and then radio waves. So light is a part of it. Sound is actually not an electromagnetic spectrum, and this is why it confuses you. So ultrasound is again a sound wave, not an electromagnetic spectrum. This is a very common repeated question in which it deliberately tries to confuse you. Ultraviolet is, water waves are not, infrared is, X-ray is, microwave is, as we can see from the spectrum. So it's going to be option D. And the reason this question is in place may look very easy is because he knows that you will confuse ultraviolet with ultrasound, and ultrasound is not an electromagnetic spectrum wave. It doesn't exist. It's a sound wave. It needs a medium, right? Okay, question number 24. Induced magnet. For induced magnetism, one of the object has to be a magnet. You see, if the switch is open in these cases, there is no current flowing through the coil and there is no magnetism in the coil. So what type of induced magnetism would be able to introduce? Nothing, and no magnetism. So option C and D get cancelled out. Option B, it's an iron bar, and an iron bar is not a guarantee of magnetism or any sort of magnetism. Plus, iron is a temporary magnet, or it's a soft magnet. So this is also cancelled out. We're left with option A because in the presence of a magnet, the other one gets magnetized, and that's why they get attracted. So for the sake of example, if this was North Pole and this was South Pole, this end of the nail would get a South Pole and this end would get a North Pole. Again, this is being induced on the nail, which is why the nail would get attracted to the magnet, or eventually will be. But if you want to understand this in a more deeper sense, what actually happens is why these poles actually come into place is because the magnetic field lines are actually flowing through them. So from the North Pole, we know that the magnetic field are pointing outwards. If you look at it from the perspective of the nail, it looks like that the magnetic field lines are coming into it. Now, we know that magnetic field lines can only come into an object if that pole is a South Pole. And if you extend those lines, they leave this terminal and then go back to the South Pole. Now, from this end, we can see that it is coming into the pole. And from this side, we can see that they're leaving the nail. So leaving magnetic fields are north, entering magnetic field are south. So again, it's a bit more complicated, but this is the science behind it. 25. Magnetic metal and non-magnetic, again, based on memory, you would have to memorize this. Aluminium and copper are not magnetic materials. So again, copper goes out. Let's make a choice now. So steel is non-magnetic. No, it's not. All right. So copper is non-magnetic. So I put the wrong ticks here. So copper is a non-magnetic material. That's true. But in terms of the magnetic metal, iron is a magnetic metal. Steel is a magnetic metal. No, iron is a magnetic metal. So this is a wrong statement. So the correct answer would be option C. So in this question, he says the magnet is freely suspended. It is held in a perpendicular uniform magnetic field. Now the magnetic field always originates. Now it looks like that this is, let's say, a North Pole, and this looks like a South Pole. And magnetic fields are always from north to south. This is how you figure out what's U and what's V. And if you allow this to move freely in its own accord, the South Pole would align with the North Pole and the North Pole would align with the South Pole, purely because of the orientation. Now this looks like an anti-clockwise rotation. It's supposed to be 90 degrees. Yes, that's true. And then it is supposed to stop moving. It should stop moving. Once it is aligned in the magnetic field, there is no more disagreement between the magnetic fields. So it should stop moving. It should be, then stops moving. So the only option in which we can see that everything comes out true is option B. Yeah. Question 27. A plastic rod becomes charged, rubbed with cloth. Okay, fine. Which statement gives the reason for the charge of the rod? Now again, a repeated question in terms of electrostatics. The rod loses protons. Now any statement involving protons is false. Protons don't move. The rod loses electron. Okay, fine. We can accept it to this point, but let's see what's the rest of the reason. becomes negative. Now losing electron makes you positive. Now lose electron and become positively charged. So yeah, because there's a net positive charge or overwhelming charge in positive direction, because there are less negative charges now. A series circuit with E and 4 identical resistors. Each resistor is R. Identical resistors. He says from left to right, what is the current in each of the resistor? So if you were to simplify this, this would become actually equal to 4 resistors, like 4R, and then that would be the battery as E. If you want to calculate the current, since it's a series circuit, the current at all points will be the same. So V equals to IR. The V in this case is E. I am not sure. And R is 4R. So current comes out as E divided by 4R. E divided by 4R, E divided by 4, E divided by 4, E divided by 4. So every point that I test, the current will remain the same, which is why the option A will be the right answer. How can 1 volt be expressed? So volt is equal to work done by charge. Sometimes young people forget about this equation, so this is going to be joules per coulomb, which is why option D makes more sense, 1 joules per 1 coulomb. Also, don't forget about the equation I equals to Q by T, V equals to IR, and then power equals to IV, I square R, and V square divided by R. These are all the equations involved in circuits, but depends how you use them. So 30, X is a piece of length of wire with the length L, A, and resistance R. So if I were to calculate the resistance of X, let's call this Rx, that would be equal to rho L over A equal to R. So whatever the value of L is, whatever the value of A is, if I put those values into this, the value will come out as R. And probably R is also an arbitrary value. He says we have another wire metal and it's made from the same material. Now, if it's same material, I don't have to think about the rho part of this equation, which deals with resistivity. I don't have to think about it. Produces a component with total resistance R by 2. Now, how should I use Y in such a way so that the total resistance becomes halved? So what are the dimensions of Y and how it is connected to X? Now, the first thing that you, by a lot of practice, you would realize that if there is already a resistor that has a resistance R, and you want to convert this into a total resistance of R by 2, you can only do this if you connect something in parallel. You can't do this in series. Why? Because no matter what resistor you add in series, it will always be added. The answer is going to get greater than R. We want something that is less than R. This is actually 0.5 R. That can only be done if it is in parallel combination or in a parallel connection. Now let's try to figure out. Now we reject option B and D, so I'm not going to check their mathematical values. I'm going to check the mathematical values for the rest of them. So let's see what happens in this case. So can I calculate the resistance over here? So resistance is equals to length over cross-sectional area. This is 2L divided by 0.25. This comes out as 8R. This also comes out as 8R. This comes out, now this, since it is 4L divided by 4A, it becomes simple R. This also becomes R. Now this makes more sense. This was already R in the previous situation. This was because of the wire X, which had a resistance R, connected another resistor or another wire in parallel, which is wire Y with the resistance R, will definitely make this equal to R by 2. If you're not convinced, what you can do is apply the formula. So this will be 1 over R plus 1 over R equals to 1 over X. This is what we're trying to find out. When you calculate this by taking the LCMs properly, you will realize that the resistance of this combination has become R by 2. So really, it is option C in this case. Moving on to question number 31, he says a fuse and a diode. So it's just a matter of labeling parts. The diode is present, but there is no fuse, so rejecting option A. B, there is a fuse present, but no diode. Option C, there is a diode, which is light emitting, but there is no fuse. Option C goes out. Option D, a diode is present and a fuse is present. So option D is the right answer. Question number 32. How energy is transferred? Again, a common question. From the power supply. So it is electrical work from the source, from the energy provider company. And since you're heating something up, it's going to increase the thermal energy. So this question was primarily based on your knowledge of the respective energies from the supply, from the supply, and where is it being converted into, because we are looking at the kettle. 33, from Lenz's law. He says that what will be the poles, or what will be the poles at P and Q while this is happening. So P, when it enters the coil, and what is at Q when it leaves the coil. So according to Lenz's law, opposite poles will be made because they want to do opposite, or they want to make sure that something opposite happens. If you're trying to bring this magnet closer, the only way P can stop this from coming closer is have the same pole as the pole you're trying to bring in to cause some repulsion. Again, we didn't do this. This is Lenz's law. This is already there. And if the magnet was moving away or leaving Q in the same orientation, again, the opposition would mean that Q should do something to attract S. And the only way we can do this is this having a north pole. So this question comes down to option A. Both will end up having a north pole, or should have a north pole, to be able to follow Lenz's law. Again, Lenz's law is not something the person whose name Lenz is did. He discovered this. Question number 34. He says a vertical wire, and you're observing the wire like this. So the current goes from the positive and comes back to the negative. So the current is moving away from you, at least from your eyes, from the observer's perspective. Now, if you were to use the right hand grip rule to find out the magnetic field, this is how you would do it. So your thumb would be representing the direction of the current, which is given in the arrow. Even if this arrow was missing, you should have been able to figure this out by looking at the poles of the battery or the terminals of the battery. This is your job. So the magnetic field around the conductor, which is of course going to be circular, is going to look something like this. It is going to make the magnetic field like this. So if you're observing it from the top, the only answer that looks like the correct one is going to be option D. Okay. Right. It's, yeah. Question number 35. He says reverses the direction of the current. That's the job of the split ring commutator. Again, part D. You can go watch the video on DC motors. I've explained this in detail. Again, this question was from memory, not from logic. 36, he says these are the nuclei notations of these components. What's R and Z? So R is the nucleon number. I can agree to that. And which is different for the isotopes of X. Yes, that is different for isotopes. R is the proton number. No, this is wrong. Proton number is Z. I'm not going to check the rest of the statement. Z is the nucleon number. No, it's the proton number. Z is a proton number, true, which is different for all the isotopes. No. For an isotope, the number of protons are same, but the number of neutrons are different, which means that the letter Z will be same for all isotopes, but letter R would be different. And a common example would be the isotopes of chlorine. So chlorine has two isotopes. This is 17 with 35 and chlorine 17 with 37. I've just memorized them to use as an example in my lessons, but of course you don't have to do that. So the number of protons remain the same in both chlorine, but number of neutrons are different, which is why when you add them together, because this number represents protons plus neutrons, this is increasing or this is different, which makes it a different number. So really, the true answer should be option A. Question number 37, he says, and this is a good question. It gets repeated many times, and it has to deal with your logic skills. And now, since he tells, now also pay more attention to this idea that if it's 2 centimeters, that means that alpha would also be in a part of the debate. It will also be checked. Sometimes what he does, he increases this distance to 10 centimeters or let's say 15 centimeters. Now, if that happens, then alpha would not be participating because alpha doesn't have this much range. It will be absorbed in the air before reaching the detector. So alpha would immediately be eliminated in those questions. But since it's 2 meters, I will be thinking or I will be considering that it should be alpha or alpha might be significant. Now it says that the background radiation is 28, which means that this is actually basically our stopping criteria. Now, what do you mean by stopping criteria? It means that if the values of the GM tube or the counter come down to 28 or 30, it means that nothing is going through this material and the detector is detecting nothing. So this is really just for your reference, that this will be the smallest value you can ever achieve with this setup. It's never going to be 0. If it becomes 28, that means everything has stopped. So it says counter reading are taken. These are the counter readings when there's no sheet. So at this moment, we can suspect that probably alpha, beta, and gamma, all three are passing through. When a thin card is placed, if it had alpha, alpha is stopped by a piece of paper, right? If it had alpha, it should have been stopped. But if the value is not decreasing, that means that alpha was not there in the source to begin with. I'm still suspecting it should have beta and gamma. When he places a thick aluminum sheet, the value reduces from 750 to 478, which confirms that beta is present. Beta is present. I can agree to that. But since there is no beta in C, I'm cancelling out C. And we have narrowed it down that alpha is also not present. Option A and B also get cancelled out. But what is the logic for gamma? You see, if it was only beta, if there was no gamma, this 750 should have come down to 28, which would have been the guarantee of beta only. But since it's still much higher than the background radiation, which means it hasn't come down to 0 or an effective 0, gamma is also present, which means the option D will be the right answer. 38. Again, the question is based on logic and reasoning. Question number 38. A radioactive isotope is injected into the patient. What would be the most suitable radiation? Emitted is detected outside the body. The radiation has to travel outside the body. So I could choose beta radiation, but then again, it stays for a few years inside the patient's body. This is a really bad practice. So the years example, for at least for the half-life, I wouldn't choose that sample. It shouldn't exist inside the body, because no matter how much ionizing it may be, it's still dangerous to have them. An alpha particle, again, what's the problem with the alpha particle? It will be absorbed inside the skin. You wouldn't be able to detect it on the outside. So this goes out, even if it has a few hours lifespan. I'm choosing a few hours because then as a doctor, I would think that the radiation level has automatically gone down with a much lower level and it has done the least damage. I have to choose gamma radiation because I can see, we know that gamma radiation penetrates everything and it comes out, or it goes through all the material there is. So option C would be the right choice in these circumstances. Question number 39. A student writes 4 statements of solar system. Which ones are true and false? We will choose. Light takes approximately this much amount of seconds. Now, again, a confusion for a student who hasn't practiced enough. This is actually the speed of light. So this is actually false. The Earth takes about 24 hours to rotate. Yes, that's true. The Moon takes 1 month to rotate the Earth. That's true. And if you go down a bit deeper, that's actually 27 days, but not exactly 1 month. But we consider this 1 month for this situation because it's probably right. Question part 4, 365 to orbit the Earth. No, this part is right, but the Sun orbiting the Earth is false, which means this is not the right answer. Only 2 and 3 are the right ones, so option C would be the right answer. Now 40 is a bit confusing. You see, he says is never formed by the explosion of a red supergiant. Now, if you see after the red giant explosion or the red giant, there are 2 lifespans. Let's check all of them. Does a black hole get formed? Yes, a black hole does get formed if it is a high massive star. So this is true. It will be formed. A neutron star. Will it ever be formed? Yes, we also have a neutron star in one of the cases. After the red giant, it will also be formed. A white dwarf. Yes, that's also present in one of the lifespans, in one of the options. It's also formed. Newer, heavier elements. Yes, they also get formed in the red giant stage, when the center core is collapsing on itself and the outer core is trying to expand outwards. That's when you get heavier elements. So if everything is correct, then which one is wrong? Which is never formed. Then you have to pay attention to the word supergiant. You see, if it is supergiant, it means it is a high massive star. So you would be following this side of the system, not this one, which is why white dwarf cannot happen. White dwarf will never be a possibility because it's a supergiant. It's super massive. And if it is super massive, it will follow this line. I'm going to clear this out so you can take a screenshot and maybe add this into your notes. It's actually taken from your books, one of the GCSE books. So I'm zooming out so you can maybe draw this in your books and have it in your notes. That is all for today. I'll see you sometime later.